Hi everyone, it's the Math Sorcerer here with Chegg. In this video, we're going to be discussing properties of logarithms. Let's do some examples of expanding using the properties of logarithms. In part A, we have log base 4 of 16 times x squared. Let's work through this solution. So we have the logarithm of a product, 16 times x squared. So there's a formula called the product rule for logs. Basically says if you have the log base b of, let's say, x times y, this is equal to the log base b of x plus the log base b of y. This one is called the product rule because it deals with products. So here we have a product. We have 16 times x squared. So in our first step, we can write this as log base 4 of 16, and then plus log base 4 of x squared using the product rule. This is equal to, in the next step we can do some math. We have log base 4 of 16. So when you look at this, you ask yourself, 4 to what power is going to give you 16? 2, and that's the answer. Plus, and here because we have an exponent on the x, we can bring it down and put it in the front. That's called the power rule. We have 2 log base 4 of x. And that would be the fully expanded form for part A. So bringing that 2 down, by the way, the power rule, let me write it here for you so you see it. Basically log base b of x to the p is equal to p times log base b of x. So if you have a number, you can just put it in the front. When you multiply, it turns into addition. All right, let's work out part B. In part B, we have the natural log of xy all over z. So we're going to need the third rule for logarithms. We already used the product rule, which is the first one here. We used the power rule. So now we need to use what's called the quotient rule. The quotient rule says if you have the log base b of x over y, when you have a fraction, it turns into subtraction. This is the log base b of x minus the log base b of y. In this particular problem, it'll be ln of xy, and then minus ln of z, just like the formula says. And then we can use another rule. We have ln of x times y. That's the product rule again. This becomes ln x plus ln y minus ln z. And this would be the fully expanded form of the natural log of xy over z. I think when you're learning this, it's really important to just pay special attention to these formulas you see on the screen. For example, in the first example, we have 16, we have x squared. So it's log of 16 plus log of x squared. Yep, we have it here. In this example here, it's ln of xy over z. So it's the natural log of the top minus natural log of the bottom. So just really pay attention to the formulas. Let's go ahead and go backwards. So given something like what we have here in our answers, we're going to try to come up with the actual question. So we're going to do the opposite of expanding, which is condensing. Let's do these examples of condensing. So in part A, we have 2 times the natural log of x plus the natural log of y. Let's work through it. Solution. In order to combine these logs with the product rule, we first need to get rid of this 2 because recall the product rule just says if you have, say, the ln of a times b, it's equal to the natural log of a plus the natural log of b. And you'll notice that there's no numbers in front of these logs. So here we have a 2. So we need to bring it up using the power rule. This is the natural log of x squared plus, and then here we have the natural log of y. Again, that was the power rule. So if you have, say, p ln x, you can write that as ln x to the p. Always you can bring those numbers up and you can bring them down. Now we're going to apply the product rule. So this will become the natural log of x squared times y. And that's it. Pretty simple example. Once you understand the rules, they're really not that bad. Solution. This one is the natural log of x minus 1 minus the natural log of x plus 1 plus the natural log of x. In this case, we're going to start with the quotient rule because we have a minus. I'll refresh your memory up here with the quotient rule. It says if you have the natural log of A, I'll write it backwards for you, minus the natural log of B, that's equal to the natural log of A over B. So here, this is our A, the x minus 1, and the B is x plus 1. This becomes the natural log of x minus 1 over x plus 1. And then we still have this plus ln x, which is kind of just hanging out there. So really important to write it. And now we can use the product rule. Whenever we have a plus, it turns into multiplication. This is the natural log of, we have x minus 1 over x plus 1 times x. You could leave it like this, but I'm going to go ahead and just put the x in the front just to make it look better. I'm going to write this as the natural log of x and then times x minus 1 over x plus 1. And you can leave it like this. You can simplify it. You can distribute the x. So like if you wanted to distribute it through the numerator, you could write it as x. Well, I think this would be better. X times x minus 1 over x plus 1. This looks cleaner than, because you could multiply it out. You could do natural log of x squared minus x, but I don't know, this looks a little bit better than that, I think. So it's up to you, I guess, where you stop. But yeah, that's it. That's how you condense. So just carefully applying these properties of logarithms. I hope this video has been helpful and hopefully you've learned some math. If you enjoyed this video, make sure to check out more videos on Chegg. Until next time, good luck.